Okay, we are doing marketing analytics with R. Today we are going to focus on, in this video, we're going to focus on statistical test. And the third one, which is the ANOVA test. ANOVA stands for analysis of variance. So let's look at the few things that we have to understand before we run the test ANOVA. ANOVA test actually test the multiple group means, if there's any difference or not, kind of thing. That's what we do using ANOVA test. ANOVA test is a parametric test. What I meant by that is, we take a sample from the entire population, and then we run statistics. We calculate statistics, and then based on the statistics, we determine the population parameters. So sample means and deviations would be used as statistics to make decisions or determine certain things about the overall population parameters, mean and the standard deviation, to be specific. This compares the means within and between groups. There's a process involved in this one that we have to follow. Number one is we have to build a model using AOV. I'm going to explain that one really quick, what that AOV function is. And then we state the hypothesis. Null hypothesis in a regular ANOVA test would be there is no significant difference among groups in terms of the mean. And the alternative hypothesis is at least one group is different. So those are the hypotheses that you will see that we can develop for this test, ANOVA test. Step 3 is going to be setting up the P cutoff value. Like we have been using, it's going to be 0.05. And then you run the test, and finally you interpret the results. One other thing is, there are essentially one-way ANOVA and two-way ANOVA test. One-way ANOVA considers only one factor, whereas two-way ANOVA considers two factors as independent variables. Now, compared to a t-test that we did last time, or in one of the previous videos, ANOVA test, if the ANOVA test establish a significant difference, then we have to run the second test, which is the post hoc test, using the Tukey test, to explore where the difference is exactly that you will find, which group has the exact difference between what groups, kind of thing. So that's something that we're going to learn in this session as well. So let me open my R Studio. I'm going to import the data set from an external source, and this is the source that I'm going to use using the read CSV file, and I'm going to save the data set as customer underscore seg, which means customer segment. That's the data set that I'm going to name it as. So let me run this code, and I have imported onto your right side in the environment. You will see that there are 300 observations and 7 variables in this data set. I am going to do, as usual, I'm going to do a basic inspection of the data set. Okay, let's do the head of the customer segment data set. That's our head in the console. You can see that. I want to find, take a look at the tail of the data set. Okay, we are good with that as well. I want to take a look at the structure by using the str function, and then we will see that these 7 variables: age is a numerical variable, gender is a character variable, income variable is a numerical variable, kids is an integer variable, you have some numbers, and then ownership, home ownership is a character variable, describe, yes or no, is a character variable, and then the last one is also a character variable, which is the segment. Now, what is the difference between the numerical variable and the integer variable? Now, numerical variables, you will find some running numbers as well, like decimal points, so on and so forth. In an integer variable, you find discrete numbers. That's the difference here. Okay, so coming back over here, we are going to compare the means within and between groups. We're going to take a look at, we're going to look at the degree to which the groups differ. The first thing that we're going to do here is we have to build a model. So before we do that, let's say that we are going to do a one-way and ANOVA test. So let's say one-way ANOVA test. By using one-way ANOVA test, what is the marketing question that we can do solve or find solution to? I would say our marketing question is going to be, what kind of marketing questions? Okay, shall we say, are the mean income across all segments equal? That's what we need to find out. So we as marketers, we need to find out in this income variable, we are trying to understand if this income, mean income, across these segments, this is the segment, across these segments are equal. That's what we're going to find out. So let's build a model first. For that, when you fit the model, we also call that fitting a model, we need to use AOV function. Now, before I do that, I would like to see visually, we need to visually see the null hypothesis. Let's do a box plot. Let's do box plot to customer. This is the data set. We use the $sign in order to pick the exact variable. In this case, we're going to talk about the income. This is going to be our response variable, and we also would like to see how income would be influenced by the segment in order to find the differences. Let's run this code, and you will see on to your right under the plots, in the plots pane, that these two are very close, moving up segment in terms of the average income and the suburb mix. These two segments are pretty much closer. This is slightly different, travelers, and if you look at the urban hip segment is way, there's a vast difference between this and these segments. Now, this is what we see visually. Now, we want to verify that one by using an ANOVA model, whether it is statistically significant. That's what we want to find out. Yes, we see some difference here visually, but we want to establish an argument to say whether this is statistically significant. So what we're going to do is we're going to build a model or fit a model. So let's use the AOV function to fit the model. AOV, let's see what AOV is. So I'm going to use the question mark AOV, and then I'm going to run this code. You will see that it is used to fit an analysis of variance model. So that's why we use AOV function. In this AOV function, we have the formula, which is explained by the tilde function, and the data, and then you have the projections. This is actually, these two are very critical for this AOV model fitting. So let's do that one. So let's say AOV, and then I'm going to say income, because we are using as a formula, income tilde. Income is our response variable, and then we need to drill it down to understand how the average income works between or across segments. So we're going to say customer segments. Segments. So let's run this code. If you run this one, okay, I made a mistake here because we need to add the data set. I forgot to do that. Data equals, we say customer, that's the data set. So let's run this one. Now, even though we ran this one, this code, I did not save it as a new object. So I'm going to save this as a new object by saying income segment compare kind of thing. So I'm going to say income dot underscore segment underscore compare. So that's how I'm going to save this model that I fit already over here by using AOV function. So I'm going to run that one. We save that one. You can see in the environment, it is saved as a new object here as income underscore seg underscore compare account. So that is a list of 13 values. So let's run the ANOVA for this one to understand if there's real difference, significant difference of the average income across the segments. So I'm going to say ANOVA, and then I'm going to call this new object that I created, income seg compare. What do we get here? Now let's read the let's try to interpret the outcome here. Now this is the analysis of variance table. Now let's interpret that table. The response variable is income. That's what we have asked for. Here you can see the income is the response variable. This is the predictor variable or independent variables. So we call this one a one-way ANOVA because we are using only one independent variable. So income is the response, and we have the degree of freedom, that is 3. We have the residuals, and then sum of squares, and then mean squares, and F value. What is this F value? Now F value is a ratio. F value is the ratio of the variance between, within, and among the groups. That's the variance that you will find as a ratio here. Now what we are really interested in here is the probability value, p value. So p value says 2.2 times 10 to the power of minus 16, which is less than the cutoff point that we regularly use, which is 0.05. So that's what our cutoff point. Therefore, this we can argue that this is a significant test. Why? When the p-value is low, we reject the null hypothesis. Now, what is the null hypothesis? Null hypothesis is, it says mean income across all segments are the same. There's no difference. So what is the alternative hypothesis? Is at least one of the segments mean income is different. That's how you. Let me write that one. A null hypothesis is going to be mean income across all segments are same. Or in other words, you can just be arguing that there's no difference. Okay, so what is the alternative hypothesis? The alternative hypothesis says that at least one of the segments, mean income is different. That's our. So when the p-value is less than 0.05, we support the alternative hypothesis. We reject the null hypothesis and we support this one. So in other words, it says at least one of the segments mean income is different. That's what it says. So that's what we read. Now here we also have to think about, even though this ANOVA significance test supports the rejection of the null hypothesis. In other words, it establishes argument that there's a significance different between or across the segments of the mean income. Now, ANOVA itself does not help us to show which segments have the differences. So it only tells us very vaguely, okay, there are some differences. That's all it says. But that this test is significant. So we need to find out where the exact difference is. In that case, we have to conduct a post hoc test to find out where the exact difference is. Now, when you do a post hoc test, what we are supposed to do is we are supposed to use a specific test, which is what we call the Tukey test. So let's run the Tukey test to understand, to explore or investigate where this exact difference is that you will find across the this thing. Okay, so what we will do is we will call a Tukey test. So I'm going to say Tukey HSD. Now you might be wondering what this HSD stands for. It stands for honest significant difference. Is other words that stand for HSD, honest significant difference. So we are trying to find out what is the honest significant difference and where it is exactly. So I'm going to say Okay, we're going to use that one, and I'm going to use the same compare the new data object that we created. You want to find exactly where the difference is. So if you hit that one, you will see that if you read the console test output, you will see that this is the fit that we created using AOV function. This is our model, and these are the segments, and this here you find the difference. You find the difference for each between two segments. This is the lower end, and the upper end, the confidence interval, and this is the probability, adjusted probability, or the p-value. So you can see the first one, the p-value is 0.8, which is greater than 0.05. So actually here, when the p-value is greater than 0.05, we accept the null hypothesis. Now the null hypothesis says there's no difference in this group between suburb mix and the moving up segment. Between these two segments, we don't find any difference. There's no difference in terms of the average income. But if you look at all the other segments, based on the p-value, it's less than 0.05. All these are significant. So you can see that there's average income difference between travelers and moving up segments, urban hip moving up segments, travelers suburb mix, and the other segments as well. So the only difference, the only two segments that you do not find any significant difference between any significant difference of the average income is only between suburb mix and the moving up segments. So this is important area for us to investigate, to understand where the exact significant difference is. Okay, so if you want to visualize this one, what you can do is we can plot this one. Let's plot this one. Let's do the plotting of the same about code line. Let's plot that one. I'm going to copy. I'm kind of lazy. I'm going to copy paste, copy, and let's see visually the difference, exact difference. You can see in this the differences are highlighted. This is the confidence interval. This is the lower bound and the upper bound, and this is the mean value of the income of this segment. And then between travelers and moving up, this is the confidence interval, and this is their average income. So they are different. What you can see is most closely is these two. I guess, yes, suburb mix and moving up. So suburb mix and moving up, suburb mix and moving up. These are the two that we do not see a significant difference between in terms of the average income. So that's how you visually see this one. Let's move on to two-way ANOVA test. So let's say two-way ANOVA test. This time we want to add one more independent variable. So let's say let's fit a model first using AOV function. So I'm going to say AOV. Let's fit the income as our response variable tilde, and let's figure out let's determine what should be our two independent variables. Let's do segments and then segment, and then we're going to say let's add to our main model by using plus sign on home, comma, we need to specify the data set that we're going to use. Data equals customer segment, that's the data set. And I want to save this new one with a new name. So I'm going to this time say income underscore segment underscore home ownership. That's what I'm going to, that's how I'm going to save this one. So let's create that new object with this model that we fit. Okay, what's the error that we get? Okay, object homeowner found. Okay, okay, let's find the names. How do we have it? Okay, let's find the names, and we can copy that one. Customer segment, home own. Okay, own home. Oh, this is lowercase. That's right. R is very sensitive. So I'm going to say own home. Now let's run this one. We created that one. I'm going to get rid of these names. We created the model. Now let's run the ANOVA for the, two-way ANOVA for this one. Okay. So let's say ANOVA. I'm going to copy paste the two-way ANOVA model that we created and the name that we saved as. When I run this one, it has the model already created, so I'm going to run that one on the ANOVA. So now you can see that what it says here is, based on the p-value, you can see that segment has some differences because the p-value is less than 0.05. Therefore, we reject the null hypothesis and we support the alternative hypothesis. At least one of the segments, there's a difference. That's what it says. So the segment has a difference, but home ownership does not have, because the home ownership probability of the p-value is greater than 0.05. So we can conclude saying that based on the model outcome, it can be concluded that segment is a significant predictor of the income variation. This means that segment and home ownerships are not independent. That's what it says. Okay. So we can hypothetically create a marketing question here. Let's look at another question here. So we're going to look at a question. Could the home ownership is related to income in some segment? So let's ask that question. Could the home ownership be related? Home ownership home ownership be related to, what was the question I had? Could the home ownership is related to income? In some segment. But not in others. Let's put it that way. That's what we want to find out. Could the home ownership be related to income in some segments, but not in others? Let's try to find out. Now, how do you find this out? In order to find this out, we need to use an interaction, measure an interaction effect. Now, when you use to measure the main effect of a model, we use the add symbol. If you want to use a interaction, then you use the colon symbol. However, this time we are going to use a star multiplication symbol. This actually measures both the main effect and also the interaction effect. So let's see, when two are interacted, how that might influence the income variable in this data set. So let's do a kind of a new model. What I'm going to do is we are going to fit a model using AOV function. So let's say AOV, and then I'm going to say income as the response variable, and then our segment is going to be our first independent variable or predictor variable interacted with home ownership, right? Comma data equals customer segment data set. I would like to save this one for future use as income underscore segment underscore home own underscore interaction. So let's save this model with this new name. Okay, let's run this one. Okay, we created that a new object as well. Now we need to run the ANOVA. How do we run the ANOVA? Using the data, new object that we created. So ANOVA income segment interaction. Let's run this one. How do we interpret this table? Okay, once again our response variable is income, and this is our these are our f values, and these are our p values. These are p values. Now what does it say? Only the segments makes an influence. Only the segment makes an influence on the income. But if you look at the other two, home ownership and the interaction, when you interact the segment and the home ownership, it's still higher than the p-value, cutoff p-value that we set, which is 0.05. In other words, we can say that when segment interacts with the home ownership, it does not influence the income factor. That's what it says. So based on the model outcome, it can be concluded that segment is a significant predictor because the p-value is less than 0.05 of the income variation. The segment and the interaction of the home ownership are not significant. In other words, we can say segment is the only significant income differentiator across the independent variable. So that's what we want to find out about it. Hope this this video is helpful for you to run ANOVA one way and to ANOVA, and also to find further using a post-hoc test, Tukey test, to understand where the exact difference is among the groups, kind of thing. So I hope this is helpful. I will see you with another video soon.